Okay, here's one way to think about this problem. We've got this function, and when we put values in for x, which are elements of the domain, which the domain is all real numbers, putting a number from the domain into the function maps it to some number in the range. And now if we could find f inverse, we want to know what is f inverse of 3? Well, 3 will, under f inverse, will map us back to the number that we started with. So we really want to find the x value that we put in here for x that will take us to 3. And then if we could find f inverse, which wouldn't be easy, by the way, that would take us back to where we started. So actually, this is the equation we want to solve. We want to know what x value we put in here for x that gives a result of 3. Then a f inverse of 3 would map us back to that. So this is the equation you want to solve for x. And you could use the rational root theorem to solve this equation. You could go to a graphing calculator, I guess. But the integer factors of negative 26 are what we call p. So that's the set of p's right there. And q is a set of integer divisors of the leading coefficient, which in this case is 1. So we want to test all these p over q possibilities, which is just going to be this set right here. And you could use synthetic division to find it out. But I think if you find out if you put 2 in for x, what's f of 2? It's 8 minus 9 times 4 is 36 plus 54 minus 23. That's 62 minus 59, which is 3. So this number right here is a 2. So when we put 2 into this function, we map to 3. F inverse of 3 would map us back to 2. So that's what f inverse of 3 is, 2. You could do the same thing for this 5, except you'd be putting a 5 here instead of a 3. And this would be minus 28. And then you'd solve that equation, and that would be the x value that mapped to 5. There you go. Hope that helped. If you have any questions, post a comment.